So this is one of the suggested problems from chapter 2, problem 58. And in this problem, you have a rocket that rises vertically from rest at an acceleration of 3.2 meters per second square until it runs out of fuel at an altitude of 950 meters. And after this point, its acceleration is that of gravity downward. And then they're asking a bunch of questions. For example, in part A, what's the velocity of the rocket when it runs out of fuel, and so on and so forth. And there are like very many parts to this question. But in fact, many of the parts are repeating, the same questions, but for different initial conditions. So as with any physics problem, we are going to try to understand what's going on. And to be able to use my formula, I'm going to start by drawing some coordinate system. Okay, so my coordinate system is going to be a regular one. So this is the ground level. The ground level is 0, and up is going to be positive x direction. So what's happening here is that, so let's say that I start from here. I go up with some acceleration of 3.2 meters per second square, and then here I run out of fuel, and then I go up and come down and possibly reach the ground. So I can actually label these positions. Let's say that I start at 0, then my fuel runs out at 1, my maximum altitude is 2. And so these are the labels that I'm going to use. And for both of these phases, from going 0 to 1 or 1 to 2, it's constant acceleration motion. But from here to here, it's positive 3.2. It's positive because acceleration is up, and I chose up as positive. But from 1 to 2, it's negative 9.8 meters per second square. But it's still constant acceleration. So it's both in the same kind. Now for part A, they're asking, what is the velocity of the rocket when it runs out of fuel? Okay. So for part A, they're asking what's V1. Essentially, V0 is 0, and so on and so forth. Now here, they're not asking about time, so the first thing that comes to my mind is to use the timeless formula, as I said many times during the lecture, to let's say 0 to 1, because there are two different accelerations here, and some delta x. And so this one is 0, I start at 0, this acceleration is 3.2, this one is given. That is, if you realize, is x1 minus x0 at delta x. And that one is going to be 950, is it? Yes, 950 meters. And so I can actually calculate V1 square. It's 2 times 3.2 times 950 meters in square root. Okay. So this part is straightforward. You just need to set things up correctly, make sure that you get the right thing, and make sure that you're not actually taking 9.8 meters per second square into account. It's not here. Okay? Whatever the thrust this rocket has, its acceleration is 3.2 meters per second square. For part B, how long does it take to reach this point? Now they're asking for, T1 minus T0. Okay? So you see, when you do the initial labeling correctly, writing down things, that's what we're looking for is very, very easy. Now, how would you do this one? Well, you're moving with acceleration, they're asking for time, you know how much distance you covered, so perhaps this one. So x1 is x0 plus v0 delta t plus 1/2 a delta t squared. Now again, this one is going to be 0. This is what I'm looking for. This is T1 minus T0. This one is 0. I start at the origin. This one is 950. And the acceleration is going to be 3.2. And that's, again, what I'm looking for. And so this is 0. This completely goes away. And you're not going to get a quadratic because there is no linear term. You're just going to get a simple square root. What is this going to be? Delta t is going to be twice x1 divided by a in square root. Okay? Now, I'm not suggesting that you memorize this or anything like that, but this is what comes out if you plug numbers in here. 950 here, 3.2 here, you're going to get your time. Do not memorize things like this. Okay? You need to memorize this. This is something that you need to know, and you need to know what delta t stands for here. It stands for T1 minus T0 in this case. And there's a formula for velocity as well, and there's a timeless formula. In principle, you can derive everything from here, right? You start with this, you take the derivative, you find the velocity formula, you solve the velocity formula for delta t, substitute into here, you get the timeless formula. But that's too much work to do in an exam. So know this one, know the velocity formula, know the timeless formula, and you should be good. But like trying to memorize things like this, I think it's a bit dangerous. You might put the two numerator, denominator. I think it's much better to start with the fundamental formulae. Okay. For part C, what maximum altitude does the rocket reach? Okay. So they're asking for, in this case, x2. Okay. For part C, they're asking for x2. And again, they're not asking about time, so timeless formula is a good candidate. What will this look like? This will look like v2 square equals v1 square plus 2. Now, going from 1 to 2, a different acceleration, times, x2 minus x1. And x1 is something we know, so if we can somehow solve this, we can get x2. So x1 is, again, 950. Or you can just solve for delta x and add it to 950 later. V1 is something we calculated in part A, so this is from part A. This one is minus 9.8. Okay. Now we are in this phase, we are in free fall, so our acceleration is minus 9.8 meters per second square. What about V2? Now this is a theme that we've seen again and again, and it comes up again and again. At the maximum altitude, your vertical velocity is going to be 0. Why? Well, because if it wasn't 0, it would move a little bit further. Yeah, that's the physical reason. Mathematically, if you draw your, x versus t graph at the maximum altitude, at the maximum value of x, the slope has to be 0. That's how you find the maximum, actually. And the slope is, of course, the derivative of x is velocity. And so at the maximum altitude, the velocity is going to be 0. And now we have one equation or one unknown. We can actually solve this. Okay, this is the only unknown. This is what you're looking for. We can easily solve this, but I'm not going to. Okay, you just plug numbers in. You also need the result from part A, but it can be done. So as you see, this is very, very similar to part A. They're asking for some quantity. They are not concerned with time, so we use the timeless formula to get our quantity. And for part D, how much time? Now they're asking for time. Total does it take to reach the maximum altitude? So now we found what that maximum altitude is. Again, we can use the formula with the time. So this is going to be x2, x1 plus v1 delta t plus 1/2 a delta t square. So this delta t now is T2 minus T1. So going from here to here, reaching the maximum altitude, you have to add that to what we found in part B, I think, to get the total time. So we'll just find that. We can't write a formula that is going to have T2 minus T0 because we have two different accelerations, and our formulas are for constant acceleration. If you have two different accelerations, it's not constant acceleration, you can't use it, but we can divide this, into two parts, piecewise constant acceleration situation. All right, so this is something we found in part C. This is, of course, 950. This is given. This was for part A, right? Part A. Delta T is what I'm looking for. And A now is minus 9.8. Okay? It's minus 9.8 because I chose up as positive and the acceleration is downward. Our velocity is up, but this doesn't make our acceleration change sign. It's always going to be down if I choose this coordinate system. If I choose up as positive, gravitational acceleration is always going to be negative. So you solve this for delta t, and then you add that delta t to the delta t you found in part B, and you get your total time. Okay? So again, this is very, very similar. You find some quantity, and then you use that quantity to find the time. Now for part E, with what velocity does it strike Earth? Okay, so let's say that I come down here, and then I'll call this final destination point 3, and they're asking for V3. my velocity at point 3. This is part E, is it? Yeah. They're asking for V3. Okay. All right, how would you do this? Well, again, this is they're not asking for time, so timeless formula is a good candidate. Let's start with this one. V3 square is V2 square plus 2a delta x. Now, delta x is our maximum altitude, so this is x3 minus x2, but this is just the maximum altitude. Okay, it's nothing, so it's something we found previously. This is our acceleration, this is minus 9.8 meters per second square. V2 square is the velocity I start with this motion. That's my velocity at the maximum altitude, that's 0. So I can just put in the numbers from the previous parts, and so for this one. And as you'd expect, x3 is 0, x2 is some positive number, so that's going to be negative. Multiplied by minus 9.8, it's going to come out positive, as it should be, because it's a square. The right-hand side should be positive as well. Now is there a part F? Yes. How long total is it in the air? It's the same story. Now they're asking about time, and to calculate the time, we need to use a formula that involves time. What did we find? We have so this is just free fall from some maximum altitude. We can solve it that way. We can say that, x3 is x2 plus v2 delta t plus 1/2 a delta t square. So this is what I'm looking for. This is the time it takes from falling from the maximum altitude to the ground level. That's what I'm looking for. How long it takes. V2 is 0. X2 is my maximum altitude. I calculated this in a previous part. My acceleration is minus 9.8. And my x3 is at the ground level. I came back, hit the ground, so this is also 0. So this is a simple equation. This actually just goes away completely, and you're going to get something really simple. This is minus 2x2 by a in square root. Again, I don't recommend that you actually memorize this or anything like that, but this is what's going to come to. You put in the maximum altitude. This is minus 9.8, so this whole ratio is going to be positive. You can take the square root and get a real number. It's just going to give you some time. Okay? And checks out dimensionally. This is meters per second square. That ratio is going to be seconds square. Its square root is going to be seconds. Okay? And that's pretty much it for this problem.